Hello there, my name's Vince from My Mate Vince, and in this video today we're going to try to fix up this Panasonic little music system here. So you can play CDs, you've got your DAB here, and you can also dock an iPod or an iPhone. It's from 2010, so it's got a bit of age to it now, but it's still a nice looking device. It's quite slim apart from the very bottom bit here. It's also designed to be wall mountable. I got it from eBay as faulty and it said it didn't power on, and that's exactly what's happening. I've got it plugged in here and there's no power whatsoever. It doesn't matter what button I press here, nothing happens. So it's supposed to slide open for the CD one way, and this front plate is supposed to slide open the other way when you use the iPod, iPhone side of things. Interestingly, it's supposed to have bamboo speakers on the inside, so I'd be curious to see what they look like. So let's bring it over to the mat and find out why it's not working. Could it be as simple as a fuse, or could the lead be faulty? We'll test it out. I doubt it. I'm sure it's going to be something on the inside, but what could that be? Let's get started. Right, model number here is SC-HC30DB, and I paid around about £7 for it, but then I had to pay £8 postage, so a little over £15. Right, let's just check the lead. By doing it this way, it would test the fuse for me as well, because if the fuse was blown, it wouldn't go through to here. So, 1 second. Yeah, so that's okay. And that's okay, and there's no short. Okay, so lead is alright, as we would expect. Let's see how you get into this thing. I hope I don't break the front when I lean it on its face. It's got quite a bit of dust, so it's definitely had a fair bit of use. So for the purpose of speeding up the video, I'm just going to whiz through the teardown, but it is an awkward thing to get into, especially the sliding door at the front, but I'll come to that a little bit later. So to begin with, I want to get to the on and off switch, because I'm thinking it could just be a problem with the on and off switch, because this is completely dead, and that's located up the top of this little sound system here. So to get into it, we need to take off the speaker grills. They are just push fit. They're held in place in 4 different locations, so you just need to ease them around with a spudger tool all the way round the speaker grill. You can't just prise from one corner, because it's kind of like male and female parts. They need to lift straight up. When I take the speaker grills off, I then uncover the bamboo speakers. So let's just play that in real time. Oh, that's nice. So that's the passive. Oh, that's the bamboo. That is the bamboo there. Just going to give that a tiny little touch. Looks like cardboard. Okay. They're nice, I like them. I like that a lot. Well, for me, the bamboo speakers were a bit of a letdown, but I don't really know what I was expecting to see. They're not there to look pretty, they're covered up anyway, but maybe they give a nice crisp sound. So now that we have the speaker grills off, it gives access to more screws up the top, which allows me to take off the top little strip. That then uncovers the circuit board that has all the buttons on, including the all-important power button. It's all held together with a little ribbon cable. So once I undo the screws and the ribbon cable, I can now test that little strip of circuit board with the switches on with my multimeter. So let's unplug this from here. It just pulls out like so, and now we can test all these switches. So they're just two prongs for each switch. Let's move this over. Let's get our meter into continuity. I reckon it's going to be a switch problem. So this is the power one over here. So let's go across the back and try to press it. Yes, I'm forcing down. It's not that. Right, let me just check all the others. I'm forcing the board down. That's how I'm getting it to press. So if it's not the switch, I think it's going to be the power supply side of it, which is a bit annoying. No, they're all alright. They're all okay. And there's a little light here that should light up. Right, okay, I mean there's a chance it's still the ribbon cable, but I think it's unlikely. So we need to get into this more. How? Well, the answer to that is that there's 2 hidden screws behind the sliding door. So if you turn the unit upside down, you will see a white little nylon cog thing that you have to move to the left or the right with your screwdriver. There are instructions for this online. And then that will allow you to kind of release the door to the left or the right. But the door still won't pop off. You're supposed to then be able to force the door up from the middle, and it's supposed to then kind of unclip so you can take it off. But I didn't want to break it, and I was using quite a bit of force, and it didn't seem to want to budge either way. So what I did is, because I took the top strip off already, I had access to, it was either 4 or 5 tiny little screws that held the top railing that the door slides on. So I just undone that, and I undone the complete rail. That then allowed the whole door to come off. So I think it was just as easy as trying to learn some weird technique. So then I undone the 2 screws. Eventually I got access inside this unit, and we'll start playing from there. Result. I'm in. So that was the thing I was moving from underneath, you see. So I suppose normally it's like that, and then you move it to here or here to release. Right, so I don't think I've broken anything apart from this bit here. So let me just push that back in. Is it going to go back in? Well, mind you, let's... we might have to get into... Oh, there we go. Yeah, okay, so that's back in there now. Alright, so there's no real harm done. So we've got 2 more screws here. They're going to hopefully release everything. Right, now I've got to do the clips. Yes, hallelujah, I'm in. I am in. We've got ribbon cables. Let's undo the ribbon cables. I'm just going to take some pictures so I know how to put it back together. Two. Excellent, right, okay, so this is the iPod dock, and it's the old-fashioned, 1632 pin connector or whatever it is. Oh, look at that. You can press that to launch it out towards you. That's quite nice to make it slightly easier to grab hold of. Right, that's your motor there. We have a display up here. Right, so we need to get to the power supply or the ribbon cable. I'm just going to do a quick continuity test because that is a hell of a bend on that ribbon cable there. And I've had it before on the JBL speaker that the ribbon cable was faulty. So let's do that before we get involved in anything else. So I'm just going to roughly go across here just to see if we have continuity, even when it's bent. Well, I think the ribbon cable's okay. So I suppose we have to look at the power supply next, which is in here. So how do we get to that? Let's undo these screws. So we have to undo a load more screws and also little connectors for the speaker and stuff in order to take this board out. But when we take the board out, it's still attached to the power supply. So even when all of it is out, guess what? We still have more screws to undo. Yes, right, okay, we're free from the casing. Now, let's undo the screw here and here. How is that even held in there by these weird connections? Right. Oh, okay. So this is the main feed here. Oh my, that was not easy to do. But what is easy to do is PCBWay. PCBWay is your one-stop solution for all things PCB fabrication and assembly. From rapid prototyping to full-scale production, PCBWay delivers top-quality products. So whether you're a seasoned engineer or a hobbyist just starting out, PCBWay's user-friendly interface makes ordering your own custom PCBs very easy. And PCBWay do a variety of different services, including but not limited to assembling your PCBs, CNC machining, 3D printing, sheet metal fabrication, and injection molding. So when you're ready to take your designs to the next level, look no further than PCBWay and bring your ideas to life. So a massive thank you as always to PCBWay for sponsoring the My Mate Vince channel. Now let's get back onto this power supply. Fingers crossed we'll be able to find something wrong with it. So now what we really need to do is there any, I'm just going to have a look for the eye loop on here, see if there's any markings to give me an indication of what might, you know, how many power rails or whatever we have here. Right, that doesn't give me any indication. So it comes onto the board here. Does this give me any indication? Well, lots of them are together. Can you see the N2 pins are together, the next 2 pins are together, the next 2 are together, the next 2 are together. So maybe this is outputting like 3 or 4 different voltages. So I think what we'll do is carefully, feel quite safe to work on that. I'm going to plug the mains in here, and I think I'm going to go across these pins to see if we have anything. Unless, of course, something on here needs to enable this, which is possible. Let's see, so I'm going to plug it in now. And let's see if we have anything on these connections. So I'm thinking the ground might be on this side. So let's go here. Nothing. Right, so unless this needs to be enabled, it looks like the power supply itself is dead. Just going to go across a few other pins. No, there's nothing happening there. Right, I've got it unplugged. Now I've got to be careful because when I take this apart, there could well be live capacitors on the inside, even though I've got it unplugged. So how does this come apart? So we have this little bit of tape here, and then it's just a clip on. So I'm gonna have to do that, aren't I? The odds of me fixing this now has suddenly gone down massively, because power supplies are just a nightmare to work on. Got to be careful. There we go. Right, look at the size of that capacitor there, 400 volts waiting to get me. So I'm going to have to undo the board in order to get to the bottom to try and discharge it. Oh, we've got a fuse. Maybe it's the fuse. Let's see, it could be the fuse. No, not the fuse. Any bulging caps? No, anything look burnt? Initially, no. Right, okay, I'm going to undo the screws. So if we have power in the capacitor, we know then that it's getting, you know, past the bridge rectifier, don't we? This big thing here would be the bridge rectifier that would turn the AC into DC. Good news is there's not a million components on here. I've seen busier power supplies. So now I've got to take this off. Got to be careful. Right, now let's see if we turn it over if we've got anything in that big cap which is here. So here and here. No, we haven't, have we? We haven't got anything in the big cap. Interesting. Right. Should we do a diode? Hold on 1 second now. Make sure. Oh, is that a burnt? 1 second. I want to see if that's burnt. No, but that looks a little bit like a bridge rectifier as well. Optocoupler here. So this is a low voltage side, and this here is the high voltage side. Can you see the demarcation? I think we're safe to work on this. I just want to stab in there so I don't get shocked. Yeah, I think we're okay to work on this. I'm just going to get an insulated screwdriver just in case anything does decide to go bang. What on earth's that? We've got a relay or something. Right, okay, I am going to, let's check the bridge rectifier. So bridge rectifier is here. So we're going to go to diode test. Nothing, nothing, nothing. Something, something, something. I think that's okay. All right, let's go from the very beginning then and try to work our way through the circuit. So it comes in here and then it goes through the fuse. So let's just go to continuity. So here, fuse, fuse. Then it goes to what looks like a, I'm not sure, something here. And then we've got this thing here, which is like a coil type thing. So it's going, that's intact. So this path is going through the fuse, going up to here, and it is going up to here. Yeah. Into this thing. I wonder, has this gone? This does look like a little bridge rectifier. Okay, let's go to diode test. Why would we have two bridge rectifiers? Nothing. 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 Something. Something. Might be okay. Right, let's check the other path. So from here, it goes to this coil, up to here, and it goes into here. So this is definitely, that's definitely a bridge rectifier. Yeah, because we've got the plus and the minus here. So it looks like we've got two bridge rectifiers. So where's this one fed from? So the AC comes in the middle. The AC comes in the middle. Into the relay? What's going on? Right, okay, I think what I'm going to have to do is, I know that this is AC and this is AC. I think we need to see if we have DC coming out of the bridge rectifiers. Because why is the capacitor not getting charged? You know what I mean? It should be coming out of here and getting charged, shouldn't it? And that should be coming straight out of the bridge rectifier. So it's like this bridge rectifier here is not working, because we should have had something on there. Okay, do not copy what you see in my videos. I'm going to be plugging this in. I'm going to keep my hands well away from it, and I want to check the outputs here on DC, and I want to check these two outputs here on DC as well. So we're on DC on our meter. Clearly, this power supply here could easily kill me. Right, we are in there. Nothing is going to fall down and harm anything. So let's plug it in now. There shouldn't be anything shorting or blowing up in my face. Right, I'm plugging it in now. Okay. Right, let's see what we're going to have on. Where's my bridge rectifier gone? On here and here. Interesting. Nothing. Right, let's go on here and here. But there we have 330 volts. Why don't we have anything here? Let's see if we've got AC going into it. So on the middle two now, here and here. No, why haven't we got AC? I'm going to unplug it. So that's the reason why that isn't, that's the reason why that capacitor's not charging. But this part of the circuit, whatever this is doing is, look at that, see that's drained already. Must be a resistor across that draining that down. Interesting. So we haven't got AC here. Why not? Let's see if we can work it out. So from here, it goes to here. And let's jump it down to here. And it goes to here. Where do you go to? See where you go to. I'm thinking I'm safe to work on this because again there's no DC in the cap, so I don't think there's anything else which is going to shock me. So we are here. What's that? That's the relay. I bet the relays fail. So is it going to the relay before, or capacitor, whatever that is it going to that before here? It is, isn't it? And how does this get over to here? Oh, this is part of the coil thing. Look. So this is part of the coil. So this is definitely getting to here. So we've got a problem with this side. This one here. Why is that not making its way back to here? So it's on a link cable. Link to... So it's on that little link, yeah? Which has to be here into this thing. So it's like the relay's not working. But where does... I don't understand where it goes. So it's in here. Five volts. 5 amp 240 volts. 5 volts DC. Has that thing failed? I don't even know where it should be going anyway. I presume it needs to jump. Well, we know that we've got voltage here, don't we? So we know that this is working to here. What? Because we've got an output here. So we know that that's working. That goes off to here, which is the low voltage side. So how does this bridge rectifier get its negative? Is it supposed to be jumping to here and it's not? Is that the problem? It must be, mustn't it? Because look, this is already, we know this is live because this is live through the coil, isn't it? From here, here, through the coil. So this is always going to be live. Yeah? So the problem we've got is it's not jumping through this relay to here. Yeah? Because once it gets to here, we are then going to have the negative of the, well, not negative, you know, like the neutral or the live of the AC. And we haven't. So 100% we've got this here. But we haven't got this here because it only goes as far as here. It needs to also go to here. But yet, so it's lining up this, so there's something wrong. It has to be wrong with this component. So let's take this component off and just to see, you know, if there's any way we can get into it. So I use my desolder station to take off the relay, and then the cover of the relay pops off with a couple of clips. There we go. Oh, we're out. So it is a relay. I'm hoping it's got dirty contacts. Let's have a real close look at this thing. Right, first things first, coil. So we should get a reading between here and here. So let's do that first of all in case the coil is broken, which it might be. And maybe that's why it's not energizing. So when that coil goes off, it sucks this in. What does it do? Does it put that out there? Or does it suck it in? No, I suppose it puts it out there. So maybe it repels this. So 1 second now. Let's pretend this is back in circuit. The coil's gone, hasn't it? Because look, if this was back in circuit, we've got, oh no, it's this side. No, it is this side. It's the staggered side. So it gets energized from here and then it pulls. So maybe it's not getting energized. Maybe there's something, oh no, I don't think this is faulty. I think there's something's not energizing it to pull it, to allow the path to go through here. I think that's the problem. Anyway, now we've got it out. Yeah, that's annoying. See, power supplies are so hard to work on. Let's see if we've got a coil reading here. Yep. Yeah, so when that coil gets energized, that's when this moves across. So clearly it's not getting energized. Unless these contacts are dirty, which is possible. So let's go to continuity. So this, if we put the leads, if I move this now with my hand, the meter should go off. Yeah. In fact, we should be able to put 5 volts on it because I think that's what it said. Yeah, 5 volts. So let's do that. Let's get 5 volts from the bench power supply and we'll put it in here and let's see if these leads here are going to start making a noise, yeah? Yeah, so what happens is when this is livened up, it creates magnetism which puts it down, which then contacts the 2 contacts, yeah? So let's get 5 volts and we should hear it switching. So if we go here and here, we should see it go across. So I'm on here. Let's see if it twitches. There, hear that? You can see it. So let's put that on there. And if I go here, you will hear that it's in contact. No, why are you not in contact? 1 second. 1 second. It definitely pulled. Let's just put this gently back on. Oh, maybe it needs to be in here to all line up. Okay, well, we know how it works. Let me just put this back on for a moment. There. And then we'll see. So, on here. I can hear it. No way. Ooh. Maybe it is this that's faulty. Unless I've just messed it up now. There's no continuity there. Well, that is fantastic news that it's not working. So, but the thing is I have been fiddling with it. Anyway, I am going to scrape up the little kind of carbon contacts that touch together when the relay is energized. Because as far as I can see, there is movement here, so the coil is working. It's just maybe the points have got a little bit tarnished. So I'm just using my tweezers and I'm just scraping very gently just the top of each of the points. And then I'm getting some isopropyl alcohol, that's 99.9%, and I'm just cleaning them with that. Then we're going to test again to see if we now have continuity. I've stripped it all down to do this. It's very straightforward to do. There's just basically like a metal bracket that pulls in towards the coil, and then there's just like a little plastic spacer. So really, when you take it apart, you can't get it wrong. It's obvious how it goes back together. I hope this is the fault, and I hope it wasn't me taking it apart that's ended up damaging it. So I'm going to go on here, and you'll see it pull in. Right, let's zoom right in so you can see it move. Right, ready? There. Now I'm sorry, but that sounds much stronger than it did earlier, don't you think? So let's see now, have we got continuity? Surely we must have continuity now. Result. Take this one off. Continuity is gone. And put it back on. Continuity is back. Result! Now, my mate Vince has his hopes up. So put this on the correct way, which is, it's got a little sort of plastic demarcation thing on the inside. So it can only go that way, it won't fit the other way. Okay, now let's turn the bench power supply back on and make sure it is working. It's lovely when you see a component on the inside like that and you fully understand how it works. Don't understand really why it's needed in the circuit. Listen to that. It was not making that lovely sound before. Brilliant. Getting worse at that. Right, I'm going to solder this back in. Fingers crossed it's going to work. Ah, brilliant. And while I'm soldering back in, I'll shout out the My Mate Vince Massive. The members this month are kitdigital.com, Kip Hakes, Max Rokotansky, Chris Seal, Felipe at MrKeebs.com, DJ VG, Pixie, Anthony Dean, Bazza2, Russ Melanson, Gaspar Heller, Rickard Bergland, Soul Reaver 555, Shamsa Al Sawadi, Stuart Park, and Stephen from the Broken Past on YouTube. Now, what do you think? Is this going to work? Of course it's going to work. It's in My Mate Vince video. Right, okay, that is soldered back in. Now, do I be brave and do it with nothing on? I just want to see, you know, if we have DC output on this bridge rectifier just here. I'm just worried now because obviously the circuit's going to be, if that is the problem, which I think it is, the circuit's going to be livened up now. And you shouldn't really run them with no load on. I'm only going to do it for a minute. Let's make sure there's nothing in the way. Okay, let's give it a go. Here goes, I'm going to plug it in now. Okay, quickly, Vince. Where am I? Here we go. What? 2 volts. No, you're still not working. What on earth? $330. Let's go to AC. So we've got nothing there. We've got nothing on the relay because we haven't got anything on the low voltage side to enable it. Okay, let's unplug it. Oh no! So maybe the relay wasn't faulty. It just didn't seem to click with any authority, and maybe just in the fact of me taking it apart, I misaligned it. Okay. Oh, what a shame. Right, I'm unplugged again. Only 2 volts there. Oh no, you're so irritating. That's so upsetting. Oh, I thought that was going to be just like the perfect fix. Oh, right, okay. So we haven't got 5 volts here. Why not? Let's follow the path. So just to recap, I'm 100% sure now the relay is working fine, but the reason we still haven't got any AC or DC voltage arriving at the bigger bridge rectifier to then feed the massive capacitor is because the relay is not being energized with the 5 volts. I tested it very quick at the end there because I didn't want the power supply on for too long, but when I went across with the meter, there's no voltage at the other 2 pins on the relay, the low voltage side, so the coil's not being energized. So I now have to work from those 2 points back. So now we have to fault find the low voltage side to find out why we haven't got the 5 volts. I kind of wanted something which was going to be a nice but not a nightmare fix. September 2010. Right, where are you two going to? So they go through that resistor, so even if that resistor was blown, it wouldn't make a difference. Let's just go to continuity. Should be safe to work on this. So we're going, does this go through here? Yes it does. Where do you go to? Is it here? Bypasses all of that and goes to here. Right, so that goes down to this area. This one goes to here. Here. So I suppose the transformer could be gone. Right, so this one goes to here. And then there's a diode. Now, why is that diode short in both ways? Let's go into diode test. I think we're going to have to take that. Problem is it's in circuit, you see. So full short there, and a full short there. But in the circuit, where does that go to? Let's zoom in and have a look here. So here it travels up, here to here. So what is, that's some weird transformer thing. So 1 second now, if that's here, so we ain't got a short here, no. Oh, well, we will have a bit of a short because there's a coil, but it's 100 ohm. But yet we've got a dead short across here. Does that suggest that maybe the diode's gone faulty? Wait a minute, this comes here. Is there anything else in circuit which would cause that short? These two, so where does that go? That goes to here. So we've got a short here. Yes, we have. So we've got a short across here. Is that normal? What is that? A capacitor. Well, we shouldn't have a short across a capacitor, should we? No, but that's interesting. And that's near enough a full short. So look at this. If I go to ohms, that doesn't look normal. Across the capacitor, can you see? 188, and my leads are like 0.8. That does not look right. I don't know. I'm going to get my desolder station back on. I want to go across this transistory thing, because these are the things that's going to be doing loads of work. So I just want to see if this is testing short. Don't think so. So why is that capacitor shorted? Because that's not even on the same line as the diode. It is on this side. Oh, hold on though. Would this be ground? 1 second. This is the ground side here. So the live has gone to ground, has it not? Maybe because of this diode. Would the diode be going down to ground? Is that a ground, I wonder? It looks to be, doesn't it, according to my meter? I think that diode's shorted. I'm just going to take a picture of it so I know which way to put it back in. It's labelled on the bottom anyway. Right, let's see. If you are shorted, wouldn't it be great if it was? Let's just go to continuity. Come on. Oh my word. You beauty. You got a full short across you, look. Wow. I wonder, has it taken out other components? Can you see there? We have a 2 ohm short. And turn it around the other way. And we have a 3 ohm short, yeah? And now if I go to diode test, you can see there we have that reading there, which is not normal. Flip this over. Did I flip it over? I don't know. Right, black lead is on the band side. And red lead on the band side. We get the same reading. That is not normal. Now, what are you? Let's see now if the short on the capacitor has gone. So, capacitor is here. Yeah, there you go, completely open. Wow! Wow! Okay. Well, it's a good job it was still necessary to look at the relay, because the thing is, but I suppose what I could have done is I could have measured for 5 volts here if I had understood the top, because that's why the path wasn't going through. The path's not going through is because we have a short on the low voltage side, so it's not providing the 5 volts. But is it just this that's faulty, and what is this? Let's zoom in and try to see. So it says 07. Right, okay, SC-HC30DB. So I've got to Google what that is. Right, I'm trying to look at like the sort of schematic for it, and this is it here, D5896, because if you look at where I've taken it out, luckily the board's labelled up and it says there D5896. Looks like a 5 because of the scrape, but it's a 6. But it doesn't say what it's for. But look, that other part of that transformer goes to grounds. So that was short into ground, wasn't it? No, that's cell phone. I'm getting confused now. I don't know what to replace it with. When I type in to Google diode equivalent, it's not really. It doesn't really say anything. See, this is just everything with that, you know, S607 in. Six amp fast recovery rectifier. I find that hard to believe, because if I look at the 6 amp ones here, look how big they are. They're these huge things compared to that. So I don't think that's going to be able to handle 6 amps. Unless, of course, they're at a lot lower voltage. Could be, couldn't they? I'm not going to know what diode to fit in here. Right, annoyingly, which is often the case, I can't find out what that diode is. It's S607, but the only things that's coming up is FR607, and they seem to be massive. They seem to be like 6 amp ones that look similar to this one here. I don't know. I think, but obviously don't copy what you see in my videos, I think I'm going to put in this one here. So that one might be a little bit low as far as the amperage. Obviously I don't need it to be 1000 volts, but I think I'm going to put the 1 amp one in and see what it does. 1N4007, but please never copy what you see in my videos, because that could be completely and utterly wrong. I don't even know what this is. It could be a Schottky diode. There's other variations of diodes as well. I don't know what that is. So I'm going to put this one in and see what happens. If it works, then I've got an outcome for the video, but I would never be happy selling this on because I don't know what that diode is. Obviously, if you know what the diode is, then if you could put it down into the comments section below, and then let me know if you think that this one here, the 1N4007, might be suitable, then again, please let me know. But yeah, I don't know what it is. So I'm just going to pop it in and see what happens. I feel slightly happier that it's on the lower voltage side of the circuit. You know, it's on this side of the circuit. But maybe it's going to feed some weird signals that will end up completely blowing up this side. I don't think it will, but still, I don't actually know. That's this diode here is not the one that's been designed to go in here. Let's just measure it, make sure that it is okay. So we have a reading one way, a sensible reading, and no reading the other way. Okay, now I feel very wary about doing this without a cover on now, because something really could go bang. Let's do it quickly and see if we have. Might be some people shouting at the screen now, no Vince. Some might be shouting, yes Vince. Ones that don't like me going on and on. Right, let's plug it in and see what it is going to do. Is it going to come alive? So we want to now go onto, I'm only going to be a few seconds, I just want to go onto the DC output of this bridge rectifier and see if anything's going to happen. Is it going to go bang straight away? I'm going to plug it in, I'm going to face the other way. So if it does go bang, I mean really it's going to be like the capacitor or something. It should kind of fire down that way, not into me. Okay, I'm plugging it in now. Okay, it hasn't gone bang. I'm going to be very quick. Very quick. Put that there. Put that there. Where am I? Where am I? I'm here. And I'm here. Don't believe you. Ha ha. I don't believe you. How can you still not be working? What? How can you still not be working? Right, I've unplugged. Unless, of course, it has to be connected. We have found a problem. We found a shorted diode, haven't we? Surely that diode's not designed to be short like that. It can't be. Right, let's go on to here. Let's see if we don't have a short on that capacitor. There's no way we would have had a short on that capacitor. Has something else also gone faulty, or do I need to plug it into the main board to see if it starts livening stuff up? I think we need to plug it into the main board, because maybe it needs to see a signal from here. See, this is why it's so hard to work on power supplies, because it's not just a power supply. It might be something on the board that's given an enable signal onto a chip on the power supply to get things working. You know, electronics is already hard enough, but when there's all different variables like this, in my opinion, it makes it near enough impossible. Okay, I'm going to balance that there. Let's plug this in and see now that it's connected to that board whether or not it comes alive. Here goes. Yes, look at that light. Yes, look at that light. Brilliant. Okay, and off. Not sure, but I heard the relay go click. So Brilliant. Well, it was the diode then, wasn't it? I'm just going to plug it in one more time. I think that click was the sound of that relay. So right now it doesn't do anything. Hit this, and I heard the relay click, and now we have the red light. Oh, fantastic. Right, I am going to put this all back together. I wonder now whether we would have a voltage in this big capacitor. Should we see, or am I going to end up blowing something? Yeah, let's balance it here. Just want to see out of curiosity. Please be here. $12 unless it's drained away. Still seems very low. Thing is, look, it wasn't doing anything before. The red light wasn't there, and now it is. So let's take it as red that it's working. It's a bit weird though. What have I got here? You only got 1 volt on that other one. Unless as soon as you turn it off it does drain. Should we turn it on like that and see what it does? Right, here we go. Let's do that again. Plug it in now. And we're going to turn on. That comes alive there. Let's see now if we've got voltage in that capacitor. Yes, we have. Look at that. 300 volts. Brilliant. That just turned itself off. Maybe it's because I went across it. Right, okay. I want to see how quickly that drains. Super quick. It's crazy. It's crazy how that drains so quick. What on earth's going on there? Yeah, because once the relay's enabled, it's gone through to there. Anyway, we've seen 320 volts or something like that. Bit worrying that it turned itself off. Maybe that's a fault, or maybe it's because I went across the capacitor and it recognised this and it wasn't happy with something. So I don't know. Anyway, I'm going to put it back together and we'll see if we have something. Right, I'm just putting it back together. I'm having to re-watch my videos because it's a bit confusing where some of the screws go. But you know what? That there just doesn't look right. But I've watched back when I've taken it apart and that's exactly how it was. I mean, that's got angles in it all over the place, unless of course this has been taken apart before, but I don't think so. There was a lot of dust and stuff in there with no fingerprints. That just looks awful. Look, we have a bend there, then a bend as if it's going to go to a right angle. This is stuck here, so, you know, if that's from a manufacturer, that really is an afterthought, and it just doesn't look right. I know they had to get it round here, but I don't understand why they didn't have a right angled one here, so, you know, bend it at an angle like that, down here, and then just in. It seems to have a load of unnecessary bends in it. And I presume, do you know what it might be? Do you reckon originally they made this without the fan, and then they had cooling problems, and then they put a fan in as an afterthought? Not sure. I suppose, well, it's on the board there, so that's unlikely, isn't it? It's just a bit strange. That just doesn't look like a Panasonic job, does it? Unless, of course, somebody has been in here. I just don't think they have. Okay, I think before we put any more screws in, it's completely safe to turn on now. So let's see if it's going to come alive. I'm slightly worried because I know that it seemed to turn itself off. So let's see what it's going to do now when we plug it in. Right, so in we go. Now, turn on. Oh, amazing. Hello. Fantastic. Right, should we see if it opens and closes? Wow. So that's the thingy one. Now, let's close that. And now do this one. Lovely. Result, 1 second now. Where's Daniel? Ah, Daniel. Let's see if it's going to spin up. DOB, it says no signal, but I haven't got a thing. I haven't got a, what's it called, a aerial in it. CD, is it? CD. No disc. There is a disc. FM. Okay, so that's FM. No disc. Oh no, don't tell me there's more faults on this. I enjoyed the fault that was there. Try DAB. Angel. Vintage, no signal. Okay, that's fine. Bass. Now, why are you not spinning up? Is there... Plugged it back in. Is it even attempting to? Oh, I can hear it moving. Reading, it says reading now. Ah, brilliant. Maybe I just needed to move that little motor. You know, it didn't move, but maybe that, the track thing, maybe just by forcing it down a little bit, it's just gone onto a new part of the motor. Maybe if it hasn't been used in ages, it might have been a bit seized up there. Ah, fantastic. Right, I'm going to put the rest back together. We can even try the iPod. Right, okay, it's back together now. Went together quite nicely. So, apart from the tiny little crack down there, I caused no other damage to it, which is a good. And you know what, your eye won't be drawn to that too much, because when it's down, there's going to be kind of shadows and stuff there. Right, I'm going to get a bit of a wet wipe, a wet cloth, and I'm just going to give everything a rub. Can you see it all looks a bit dirty and stained around the place? And just give everything a nice clean, like in here. At the back of the passive speakers, can you see they're all dusty and in here and stuff? So I'm just going to give it a nice good clean. I'm not sure what that port there is for. It must be some sort of programming port. Looks like USB-C, but this is before the days of USB-C. So yeah, I don't know what that is.
A little different than all the rest. I'm quite old-fashioned where I had sometimes played chess. And when I'm out, I'm looking for that vintage fling. But all complexions that I adore, so hard to find, they seem impossible to score. So I dream on to someday find that vintage love. The lights were dimmed as our eyes met, moves on me, and forevermore I like to share that vintage dream.
Wow. Look how nice that's come out. In fact, you can see a reflection of me. Check that out. That's come out really, really nice. And all the grime around the buttons has now gone. It's come out really good. Right, let's play a bit of Nine Violets. Thank you, Matt. And see what it sounds like. Okay, I've been messing with it, and because it didn't come with a remote control for me, there's a lot of features that I can't do, so I couldn't get the DAB to work. But what I did is I initialized it, in other words I reset it, which involves unplugging the AC lead from it, leaving it for 3 minutes, and then holding down the power button while plugging the AC lead in. And then when it comes up with a load of dashes, you take your hand off the power button. Then when I turned it on next time and went onto DAB, it did a scan. Now I've got to be really careful with copyright, so I can't show you the DAB or the iPod working, but I will do just for 1 second. So check this out, DAB. It will kick in a second. There we go. Okay, that's DAB. FM is also, hopefully you'll hear some noise in a second. There you go. And if I go to iPod, stop. There we go. Okay, and I can skip the things on the iPod as well. Hopefully you can hear it down here. So if I was to press play, is it play now? Right, play. There we go. I can't play any more of that purely for copyright. But what I can play you is 9 Violets. So it all appears to be working fine. Sound quality is not going to be up there with the Zeppelin speaker or Bang & Olufsen product. But the thing is, it's going to be 1/5 or 1/10 of the price. And I think it looks nice and stylish, really, considering it's 14 years old. I don't think that would embarrass anybody having that on their living room side table. I'm in the back room at the moment. I know it doesn't look very nice here. It's just everybody's in bed and I don't want to wake them up. It goes all the way up to 50 on the volume and it's pretty loud. So it's not going to win any awards for the sound quality, but it was £185 and it does what it needs to do. So I can see why people would like it. And to be fair, it does look quite nice. In fact, it reminds me of a Bang & Olufsen product from maybe 15 or 20 years prior to this. So yeah, that is it. Let me show you the CD player working. As soon as I plugged the iPod in, it started to work. And yeah, that's it. So I love faults like that. That there is perfect. The fault finding there is a dream come true for a YouTube video because there's not a million things wrong with it. It was just one diode, and it was nice that we could follow the path with the multimeter that led me to the relay. I thought the relay was faulty. In my opinion, it seems to be working better than it did before because it's more clicky than it was before. Maybe the relay was dodgy, but 100% the diode here was dodgy. If you know that the diode that I've put in is going to be okay, let me know. If you know for sure it's not going to be okay, again, let me know. Don't just guess. I'm talking about the people that watch my channel that actually know. If you know what this diode is, again, please put it down in the comment section below, and then I will buy the correct diode for it. But this does appear to be working now, but I don't know if it's safe or not because I don't know exactly what that diode does in the circuit. So that is it for this video. I'm going to play you out now with some 9 Violets. I'm going to go to 1, 2, 3, 4, 5. I will let you down. If you enjoyed this video, give it a massive thumbs up. I'll show you the bass working on and off when I play this song here. So CD. And we'll go to number 5. So that's volume halfway. And this will be bass on. And this is bass off. That's bass off. I'm not sure what it was before. Hold on. On, off. That's it. I personally prefer it off. You can also do aux in on it as well. Right, I'll be quiet now. Enjoy the song.